This is part 14 in a series of videos in which I'm attempting to repair an IBM 5120 computer system. If you've watched the previous videos, then you'll know that the unit was in a terrible state when I first got it. It doesn't belong to me, it belongs to somebody else, but I'm trying to get it into as good a state as I can. I'm not sure if I can repair it yet, but that's what the intention is at the moment. I've been through the main chassis, and initially the electronics were completely dead, but I've got some activity on the video sync lines, and the next thing I wanted to do was to try and get some activity in the main processor. A comment in the previous video said that it may have got to the point where it was waiting for a response from the floppy drives. Now, I had considered that, but at the time there was no activity on the lines that these cables plug into. So in the previous video I showed where these plug into, but there wasn't anything on the connectors going to these. Now I've worked my way through some of the cards on the main motherboard. Apologies for not showing that, but it's an extremely tedious process because it's almost entirely the IBM sealed modules, which means that I'm constantly moving from one module to another, trying to figure out exactly what's going on. Now I finally got to the point where I'm seeing some activity on the connector that this plugs into. So still nothing on the screen of the main unit, but we may now be at the point where it's looking for something on the floppy drive. So I need to get these floppy drives up to a point where at least they, in theory, are functional. So 8-inch floppy drives, there's a pair of them, immensely heavy drives. I think this weighs about 30 pounds or more, this entire assembly. I've started taking the screening off, so I'll get the rest of it off and then separate the two drives. So we've got this metal screening, two drives, a spring clip at the top, and they're held together at the bottom, mostly with the screening. So I'll take the screening off. Now, one of the problems with this machine has been the amount of corrosion in it, and luckily this assembly sits quite high up in the chassis, but even so there's quite a lot of corrosion on the various screws. So one thing I found that seems to work best to try and get steel screws out of aluminium without stripping them or wringing the heads out is an impact screwdriver. Normally it will get them out fairly quickly and easily. So I'll just lower the camera so you can see what I'm doing. Okay, and now we'll try to get the screws out. I've got this on the lowest setting it will go on, and if I just take it easy, normally it will spin them out relatively easily. There we go. The first few bumps of the hammer action freeze them up and they come out, but they're normally extremely tight. So that's the first one out. I'll spin it round and get the second one out. Okay, that's the second one off. So what I need to do now is to get this screw out, and then I should be able to pop the screen completely off and get that out of the way, and we can start then looking at the drives themselves. Okay, so that's out of the way. I'll just raise the camera. Okay, we've got some wildlife in here by the look of it, so this will need cleaning out very carefully. So what I need to do now is get these spring clips off. These are not screwed together, there's just a few spring clips that hold them together, and it should be fairly easy to get these off. That's the first one, and there's two at the bottom, one at the top, so I'll get these out of the way. Rock it back down. Let's move it so you can see it a bit better. And then if I take this one off, the two should come apart. They're identical, apart from the catches on this one. For some reason one's got a bit of an odd catch. Take this one off and then the two should separate. Okay. Okay, and as expected, they won't turn. Try the other one. buttons frozen as well. Okay, so these are the modules I was talking about, and unfortunately these are everywhere on this machine, and so it's a real pain having to trace through, because you can't follow the traces on top or the bottom of the board. They just disappear into these modules. Then you've got to try to figure out what the particular module is, what the pins are connected to, and the information available on these is very sketchy, so it's a very slow and tedious process. But what I'm going to do with this is give it a full service. It obviously needs cleaning. Okay, so that's not really turning, it's just skipping on its ratchet, so that needs cleaning as well. I won't move it too much, a lot of dirt and debris in here. And that's a bit sticky as well. Okay, so what I'll do is I'll get these over to the workshop, I'll get them cleared out, and then we'll look at trying to free them up. I suspect the bearings are rusted up, so I will need to take those out and see if the bearings actually need replacing. It is quite easy to get them out, but I need to get them over to the workshop and onto the press to do that. So I'll get these cleaned up, and then I'll get back on camera, and we'll look to see what the general condition is that they're in. If you're interested, this says October 1980, Alpha Electronics, and the part number is 6842851. See if they're both the same. Yeah, they're exactly the same part number on them both, same date. The other thing that's I'm wondering about is why they've got different handles on the front, whether one was broken at some point and replaced, or whether that's the way it was when it was made. The only ones I've ever seen in the past look like this. It's a bit sticky as well. Okay, well, there's a lot of dirt and muck falling out of these. And if you're interested, this has got looks like DF written on it. That's some of his initials out, I'm not quite sure. That one has nothing on. Okay, but certainly fairly significant drives. So, as I say, I'll get these cleaned up, get back on camera, and then we'll see if they can be freed up. And the next step will be to plug them into the main unit and see if we get any further through the boot up process. So I spent a few minutes looking at these drives more carefully and found that there were several broken parts in some of them. I think it's just age. Some parts have just crumbled away to almost nothing. So I've started cleaning them up, but it became apparent I was going to have to fully dismantle them. So I've taken it apart as I've been cleaning it. I still have a lot of cleaning to do on the plastic parts, but I've been focusing firstly on the chassis. I've freed up the head and took the bearings out and lubricated that. That's now nice and free. And spins quite nicely. I need to clean up the pulley, so I'll pop that back off. And what I'm doing here, luckily I've got two drives, so I'm using one as a template so I can rebuild the other one. The head load solenoid was frozen, so I freed that up as well. That's now nice and free. The head slide I need to take out, but I've got to be very careful doing that because I don't want to upset the alignment of it. But it is partially seized, so I need to take it out and lubricate it. What I'll probably do is loosen off one side. I'll turn it over so I can explain what I intend to do. So these are frozen in here or partly seized up, so what I intend to do is take two screws out of one side, turn the head up so I can slide or try and slide the guide bar out, clean it up, polish it, clean the bearings, put it back in, put the head back down, put the screws back, and then do the same on the other side. And I'm hoping doing it that way I can avoid upsetting the alignment of this too much, because it is fairly critical to get this back exactly as it's come out. So I won't be removing these screws or the screws that hold the motor in, for example. And then I can clean the rest of it up. Incidentally, this comes out fairly easy. It just needs pressing out from the other side. and this was in fairly good condition. The main problem with the drive is the motor itself. I think I showed in a recent video on some 8-inch drives how to replace the bearings on these motors, so this one's definitely a candidate for a new set of bearings. I've also taken out the PCB. It needs cleaning. It's not actually too bad, but it's got some corrosion on the connector pins, so not to be too surprising for this machine, but as you can see, it needs a good cleaning, so I'll give that a good bath, get rid of all this corrosion. Got the same problem with the cables, of course, so I'll clean those as well. And then it's on to the plastic parts. Got to be very careful on machines of this age when they've got plastic. It is very brittle, and again, some parts I do not want to disturb the adjustment, so I've been taking this apart in a fairly measured way to make sure I don't upset the alignment of certain parts. But I do need to replace this bushing in here. It's disintegrating. That's some of the parts I showed a few minutes ago. As you can see, it's just falling to pieces, so every time I move it, another piece falls off it. So I will need to make up a replacement bushing for that. The rest of it's not too bad, just needs a bit of de-rusting here and there, and then it's just really a case of giving it a very good clean. Luckily the head pressure, the location guide is fairly free, but it does need a new bearing in it. This one's quite tight. I'm going to take it out, see if I can clean it, but I might need to replace the bearing in that. And then the rest of it is just really a case of cleaning up all the debris, and then putting it back on and hoping it lines up as it's supposed to. So that's where I am at the moment. It's going to take an hour or so to get these cleaned, and then, as I said, the next step is to get it all assembled and then try and power them up and see if they spin up. They spin up under the control of the main processor, so it will kind of be indicative of as to the state of run of the processor as to what we see in terms of signals coming from this. Whether or not this works, I've got no idea, but luckily there are two, so unless both have identical faults, I can at least use one to compare against the other. Of course, I won't know which one's working and which one's not, so it's a case of I hope I don't find any differences between the two, and if I do, I'll have to try and figure out which one's actually working. Okay, so certainly an interesting machine. Luckily drives did move on quite a bit from this as they developed, but certainly a fascinating piece of equipment, and with any luck we can get this up and running. Okay, I've made some progress. I've been going through the chassis, addressing all the issues I've come across as I've found each one, and I'm very close now to being able to reassemble this unit. For the motor, I didn't need to replace the bearings in the end. I was able to clean these, took them out and took the grease and the dirt and the rust out of them, re-lubricated them. I'll show that process in a separate video, otherwise this video will get too long. I have shown dealing with motors in a previous video and replacing bearings, but for this particular one, as I say, I didn't replace them, I just cleaned them and they look fine, but I'll post that process separately. I've cleaned up all the parts as I've gone through, checked that the sensors, so these are the sector hole sensors, and they work fine. All the pivots, springs, etc. I've taken out and I've de-rusted. I've taken out the board and given that a good clean. I've done a bit of testing on this, static testing, just using a multimeter on ohms range, looking for shorts and that sort of thing, and it measures fine so far. I took the bearing out of the pressure plate and cleaned that, and that now spins nice and freely. I've de-rusted all the clamps and cleaned up the pulleys, and we'll look at the chassis in a minute. I've done some cleaning on that as well. I've given everything a really good clean, so it's all now in very good clean condition. Just one thing left to do, which is to try and address the problem with this pulley, this roller. So this sits through this hole, and it's operated by the open close lever. So when you open and close the drive using the lever on the front, it rotates this, and it's this roller supposed to roll up and down this curved surface, and the idea there is a kind of reaction against it doing that. It opens or lifts the head off the disc, and it also opens the drive. So assuming that it's in a closed position and you're reading the disc, when you rotate the handle, it not only lifts the pressure plate off the disc to disengage the disc from the drive, but if the head load solenoid is engaged, it overrides that and it lifts the head away from the disc to make sure that the disc and the head aren't damaged. But for it to work, this roller needs to be the right size, and it also needs to rotate freely. The problem is, of course, I don't know the size it should be. So what I've been doing is, with this in the correct, or what appears to be the correct position, I've measured the distance between the center of the pin and the surface on which the roller runs, working on the assumption that that's the position it should run up and down in. And what I will do, this has got a brass insert in the center. This brown stuff around the outside, I assume at one point was supposed to be a kind of rubber material, and it gives a nice smooth operation, so it doesn't feel like you're grinding plastic against plastic. So what I've done is I've gone through the various materials I have to hand, and the most promising is a piece of hard silicon tubing that's the right size. The outside diameter seems to match what is required, and so what I'll do is I'll cut a short length of this, clean up the brass roller, and then I'll bond this onto the roller and test it to make sure that it works, and that will give us a nice smooth operation, and hopefully will be fairly resilient as well. So I'll do that, then we'll get back on camera and start reassembling the drive. Okay, so I've put what amounts to a tyre on the outside of the roller, and it does appear to be the right size. When I put this into position, it does appear to locate the rod in exactly the right place, and as it's rotated, it does run smoothly up and down the ramp. I won't know for sure until I've finished assembling it, but it looks good so far. And the next thing to do is we'll have a quick look at the main chassis, and then we can start the reassembly process. Let's get these out of the way. So what I've done with the main chassis so far is I took out the guide rods one at a time. There's one that sits in a pair of bushes either end of the main head assembly, and the other side is just in a slot. So the one side's kind of semi-floating and it's captive on the side nearest to us. And the one on this side, it would only go so far across and then it bound up and then it wouldn't go back. So there's quite a lot of corrosion on the actual shaft. So I took them out, put them in the lathe, and used 7000 grit wet and dry paper and oil to polish them up, and then I used some metal polish, and they've come up extremely clean. I've also cleaned the drive cup, so that's now cleaned up. That came up very nice. There are no pits, and it is important these parts are smooth. So this bit is what this thing drops into, and it engages with the floppy disk to drive the disk. And it is important that these work extremely well, otherwise you'll just destroy any disk that you put in this. And also, of course, it's important that the head load mechanism works properly. Single-sided drive, so the head's at the top, the bottom's just got a pressure pad. Cleaned up the sensor for the sector optics. Made sure that the head load roller is free. That was actually fine. Checked everything else, given it a good clean. Then on the bottom, I've cleaned up the outside of this disc. You quite often find when these have been sitting for a long time, especially in a damp environment, where the belt contacts the drive, you get moisture trapped between the belt and the pulley, and you get corrosion and pitting. There's very minor pitting on this, you can barely feel it, so I've cleaned it up I'm not going to turn this down on the lathe as I did in the previous video that I showed a drive on. It's not that bad, so that can be left. I've taken the bearings out on this and cleaned this as well. I have not removed the stepper motor. I don't want to mess with the alignment of that. It is fairly critical, and we'll just have to see if it works when we reassemble it. It measures okay, but we won't know for sure until we try running the drive. And as I said, I have cleaned and lubricated the guides that the head runs on, so and it moves quite freely. When you're dealing with drives like this, if something hasn't been lubricated previously, then in general they are designed for most parts to run dry. So don't be too overzealous trying to put grease and whatever else on it, because it will very rapidly attract dirt and grime, and it will grind to a standstill. Okay, so the next thing to do is to start reassembly. There's no set way to do this, it's just making sure that it's assembled in an order that you don't fit something that's going to get in the way of fitting something else. So we'll start by reassembling the sub-chassis, and I'm going to pretty much do the reverse of what I did to dismantle it. So I'm going to start by refitting the optical sensor. So that has just a connector that goes through a few slots and guides on this sub-chassis. Of course, you've got to be fairly careful on old pieces of equipment like this. The wire and the plastic can be fairly brittle. And then that fits so that the two sensors locate through the hole. Like that. Try not to get in the way of the camera. Tighten down the screw. Okay, the next thing I want to fit is the head release guide. So this is responsible for raising and lowering the head, read-write head, onto the floppy disk, and it is operated by the head load solenoid, which hooks onto this little lever here. We'll look at that in a few minutes. And the way this whole thing's arranged is, if the disk is actually in the drive and is being read, and you open the door lever, then the head load solenoid is overridden and it pulls this up, and it disengages the head from the read position, the loaded position, and it also disengages the drive from the floppy disk. So we need to reassemble this. So firstly we need to put the lever through the sub-chassis, and then this bolts to the release lever, and we need to make sure this goes into the right position. So the way this is arranged is, when this is in the closed position like this, then this lever should be in the down position. So when it's raised, it only goes one way of course, when it's raised it will move this way. So that looks correct, so I'll put the screw in, and then there's a nut that holds that captive. Okay, so what I'm doing here now is I'm just trying to get this properly aligned. So if it's not tightened so that these two are in line, then this will tend to bind up as you rotate it. So I'm trying to adjust it so that it's free to rotate through its entire range. It's just a little bit tight at one end at the moment, so let's get this adjusted. Okay, so that's now properly adjusted. As you can see, the purpose of this roller is there's a recess at the bottom, and when the lever's in this position, it's kind of sitting in the door closed position. But when you open it, this roller engages with the ramp and it gives you some resistance and then when it gets to the top it will pop over this little shoulder, and it will kind of gives it a positive location so that it's then in the door open position. So that seems to be working correctly. It's got kind of a nice feel to it without being too tight. And so the next thing to do is to fit the release lever, which is this, and that fits, basically it goes, this slot fits over this boss, and then this loose end sits in here. So it's just making sure we put it on the right way up, of course. It goes on with the cup facing down, and it's just really just a piece of spring steel that we need to work into the right location. So, like so. And then this fits over like this. So what we should see now is as we turn the lever, it should push the drive cup down and pop into position, which it does. And then when we turn the handle the other way, it should be a nice positive disengage. Let's show that from the other side as well. Okay, so next thing we have to do is fit the head release plate, which is this. So this end fits in like this, and then there's a guide bar goes through the pivot points, and then there's a small spring underneath that's used to keep this kind of pushed in one direction all the time. So the spring goes into this recess. We have to put the pivot pin through the plate. We can actually do that once it's in place. We just need to make sure the spring doesn't fall out and that the lever engages in its slot. Okay, and then we can fit the pin into place. And then the whole lot's held down with a screw. And so what we should now see is that with the door open, everything is raised, so that allows you to put a disc in, and it makes sure the head's lifted off the disc read position. And then when we turn the lever, it should all move down, and then this is now controlled by the head load solenoid. So this is still in the raised position, or partly raised position, but when you try to read the drive, the head load solenoid will pull this down, and it will engage the read-write heads or bring it into contact with the disc. But if you're in the read position and you open the door, then you don't want to try and remove the disc while the head is in the load position. So this lever will override the head load solenoid, and it will force the head back into the disengaged position. Okay, so that's this part completed. We can now refit this to the main chassis. So this is the head load solenoid actuator wire, and the solenoid's of course on the underside. I checked everything else to make sure it's all aligned, nothing's broken, everything's lubricated, and so the next thing is to refit this. So it's just held in place with a few screws, but we do need to make sure that this slide engages with the head. Okay, so as you can see, this will now allow the head to raise and lower. So if I close the drive, you can see it allows this the authority to lower the head onto the disc, but when you open the door it forces it into the disengaged position. Okay, so I'll just refit the screws that hold this in place. Okay, so that's now bolted into position. Next thing to do is re-engage the head load solenoid. So we need to make sure the cable sits on its little pulley, and then that simply clips onto this little wire link up here. Okay. So that's this side done. Next thing we need to do is flip it over and get the PCB refitted to the underside of the chassis. So making sure all the wires are on top, we don't want them kind of captive underneath the PCB. This goes into a carrier. So the PCB fits into this carrier, and then the whole thing drops down into the chassis. And I'm making sure that none of the wires are trapped between the carrier okay, that looks fine. And then we refit the screws that hold that assembly in place. Okay, so that's all in. The board is now secured. All I have to do now is reconnect all the plugs, make sure I get them in the right place, and most of them have keys, so you can't really put them in offset or the wrong way around. You just need to make sure that they're lined up before you try and press them on so you don't bend any of the pins. So the last thing we have to do is to refit the motor. So we'll start by putting the fan back onto it. And the motor shaft does have a flat, and there is a set screw in the boss of the pulley. So we'll make sure we've got that properly lined up with a flat on the pulley, on the motor itself. Now what I'm doing here is, I can't really show this on camera, but to make sure this pulley has gone back in the same position that it came off, I'm looking down through the hole that the set screw came out of. I'm looking for the mark that was left. There'll be a witness mark on the shaft that was left by the set screw, and you can't see it on camera, I shouldn't think, but I've now got that lined up so it's central in the set screw hole, so I can be confident now that I've got the pulley in the correct place on the shaft, and I can now put the set screw back in and lock that into place. Does not need to be horrendously tight. Okay, and next thing is to get the motor fitted back into the chassis. So we'll start by popping the capacitor back in. Refit the capacitor clamp screw. So we've got this shroud that fits on the bottom of the motor, and it's fairly obvious which way this goes. There's this slot in it, it's a weird looking slot, and that's for the belt to run in. So we need to make sure that that's effectively pointing towards this pulley, otherwise you won't be able to refit the belt. And then of course we put a screw in, and that goes all the way through and engages with the motor on the other side. Okay, that's the first one in. I'll do the same on the opposite side. This shroud, by the way, does engage with the motor, so there is a cutout in it to make sure it's properly aligned, and if it's not properly aligned you won't be able to properly tighten the screws. They might start, and if you're not careful you try and tighten them, you'll probably shatter the shroud. Okay, that's the motor bolted into place. It spins freely, so we now just need to refit the belt. So almost totally silent when it turns, which is what it should be. The belt's a little bit slack, but it should be okay. It's quite a wide belt, so it doesn't need to be particularly tight. But certainly there's no noise now coming from the motor, which is the way it should be. So that's the first one done. It obviously looks far better than it did. It all seems to work. It engages and disengages the way it should do. The head load solenoid again does what it's supposed to do, so if I pull the head load solenoid in, you can see that it's loading the head. If I open the drive door, then it disengages the drive and also raises the head out of the way. So it feels nice in operation, it's got a nice positive action, and of course it looks a lot better than it did. So that's the first one done. I now have to repeat the process on the second drive. Let's raise the camera a bit. So I now have to do exactly the same thing I've done to this drive on the second one, and then once I've got this done, we can try refitting the drives to the main chassis. I don't believe it will actually cause the unit to boot. I don't think it will make any difference, but I'll explain why I think that later in the next video. But it really comes down to because of what the machine is doing when you first boot it up. But as I say, we'll look at that in the next video and go from there. But I want to get all the mechanical work out of the way, and the drives are the last part of that. So once these two drives are finished and refitted to the chassis, then the only thing that's left is the electronics, so we can start concentrating on that. But I don't believe that simply plugging these drives in will make any difference. As I say, I'll explain why in the next video. Any comments, welcome. Again, if you have any documentation for this, or especially schematics, then I'd appreciate a copy.